Right, I'm reading from the geography textbook, page 64 to 69. This is the beginning of chapter 4. Chapter 4 is about landforms and rivers. The people of the tropical island of Sumatra, Indonesia, were going about their morning activities. Tourists from around the world were enjoying a holiday on the beach. Little fishing boats bobbed gently on the turquoise water. Then, two unusual things took place. First, the ocean shrank back, exposing a wide area of ocean floor. Then, within minutes, a long ridge appeared on the horizon, moving quickly toward the beach. As it approached, it grew larger, the top white with foam. Suddenly, the boats were tossed into the air like toys. People ran for their lives, but for most, it was too late. The first wave struck the beach seconds later. It drove through the line of palm trees and surged against homes and hotels. Two larger waves surged forward, 30 minutes apart, pushing into seaside towns, destroying everything. In a few hours, it was all over, one of the worst such disasters ever known. The waves, called tsunamis, were caused by an undersea earthquake. More than 230,000 people died in the Southeast Asian tsunamis of December 26, 2004. It was an awesome display of nature's power. And if we look here at the words matter, tsunami is a long, high wave caused by an undersea earthquake, a Japanese term meaning harbor wave. So the things that we'll be looking at in this chapter: what are the effects of earthquakes and volcanoes? What are landforms and the world landform patterns? What are the major river systems of the world? And how can I interpret landform features using contour lines on a topographic map? And how can I draw a cross-section diagram to show landform features? And then looking at page 66. Natural disasters in the news. Often you hear and see striking information about natural disasters. The tsunamis of 2004 are one such example, caused by an earthquake under the Indian Ocean. Volcanoes and landslides are other landform processes that have dramatic effects. If we look on the side here, landform processes are changes that occur in landforms. In 1903, part of the town of Frank, Alberta, was buried when 74 million tons of rock slid down the side of nearby Turtle Mountain in the middle of the night. At least 70 people died. Tornadoes, hurricanes, blizzards, and snow avalanches can all take lives and cause damage and disruption. What causes a tsunami? True story. One summer, Danny and his friends started bobbing up and down together in the family's above-ground pool. They soon got a wave going back and forth. As it grew higher, it knocked over the end wall of the pool close to the house and smashed through a low window. The basement was quickly flooded with 30 centimeters of water. Danny's homemade tsunami shows how destructive the force of water can be. A pailful is heavy, and a pool full weighs many tons. A 30-meter ocean tsunami crashes against the shore with great force. The Southeast Asian tsunami knocked over an entire train and ripped up the tracks. In low-lying areas, it left a trail of destruction that reached several kilometers inland. Millions of people were homeless as communities were reduced to rubble. A tsunami is a special type of wave. It is sometimes mistakenly referred to as a tidal wave, but it is not related to the pull of the moon's gravity on the world's oceans. Nor is it like a storm surge, a sudden rise in sea level caused by high winds generated by storms and hurricanes that whip up the water. Other such ocean surges can occur when a massive landslide or a huge ice block breaking away from Greenland or Antarctica displaces water suddenly. A tsunami is different because it is caused when an earthquake shakes the ocean floor itself. When this happens, shock tremors race through the water outward in a circular pattern. You could see the same effect by dropping a large stone into a pond. Looking at the words matter section, tidal wave is the bulge in the ocean's surface caused by the pull of the moon's gravity, which becomes high tide at each place it travels to. And storm surge, the sudden rise in sea level caused by high winds pushing water toward coastlines. Scientists know that tremors travel about 10 times faster than the crest of the water, the tsunami, than that the motion creates. By measuring the speed of the tremor, they can estimate how long the tsunami will take to reach any part of the ocean basin. Why do earthquakes occur? The thin skin of the earth is constantly twitching and trembling. An earthquake shakes the planet about every 3 minutes, or 180,000 times a year. Most earthquakes are not strong enough to do any damage, but bigger ones have enormous destructive power. Loss of life is especially extensive when earthquakes occur in heavily populated regions without earthquake-proof buildings. And here are some of the deadliest earthquakes since 1995. Sumatra, in Pakistan in 2005, in India in 2001, in Turkey in 1999, and in Indonesia 2006. One that's more recent than that was in Haiti, I think in 2011. Zones of the Earth. Earthquakes occur because the planet's skin, the crust, is in motion. The planet is like a round egg. Scientists use the speed of the earthquake tremors passing through the Earth to identify 3 layers. Core, or the yolk, a very hot, dense zone under intense pressure from the weight of overlying rock material. Mantle, or the egg white, a zone of thick, molten rock called magma, slowly moving in broad currents. And there's the crust, the eggshell, a thin, brittle shell broken into several pieces called plates and floating on the mantle. Scientists believe that the currents beneath the crust slowly move the plates around. Earthquakes occur as plates are ripped apart, hauled together, or dragged alongside one another. Rock under tension can bend a bit until it snaps and moves several centimeters all at once. Tremendous energy is released at the breakpoint, called the epicenter. The Richter scale is a 10-point scale used to measure the strength of an earthquake. The Sumatra earthquake of December 2004, the cause of the tsunamis, reached 9.2, a very high reading, and lasted for about 10 minutes, the longest ever recorded. Scientists estimate that it released as much energy as Canadians would use in 4 months. And then words matter. Epicenter is the break point where the Earth's plate moves suddenly, causing an earthquake. You can see here the plates of the Earth's crust, and the epicenter is where they kind of rub together, and then it causes that wave.